Hello everyone, this is Florian, and today's video is about creating a context manager in Python measuring the execution time of a certain piece of code. In essence, two approaches exist. The first one is the class-based approach, the second one is the generator-based approach. We will have a look at both of them. Let's start by creating a new file. We call this one script.py for simplicity and open it in Visual Studio Code. Let's start with a class-based approach. In order to do so, we create a new class and call this one timer. To turn this class into a proper context manager, we need to implement two functions. The first one is called $enter, and the other one is called $exit. The $exit takes a couple of more arguments than just the self one. There is a type, there is a value, and a traceback. We don't really care about them in this video, but they do exist, and this is the signature of the method. All right. So what do these two methods do? So if the context is entered, the $enter method is invoked. If the context is left, the $exit method is invoked. What we would like to do in order to measure the execution time is that we first take the current time when the context is entered, and we do this by calling the type function from the time module and assign it to the class attribute called start. And if the context is left, we want to measure the current time as well. And now we also want to compute the elapsed time, which is the time at the end minus the time at the start, and we want to print it to the terminal. So this looks already pretty good. What I would like to do is to also give the user the opportunity to specify some description, which is also printed to the terminal. So we need to overload the init method, which takes a description a user can specify. So .description equals description. And this description is also printed at the end. So self.description. And yeah, that's already it. And now let's hit over and try to use this context manager. And we do this by creating a new with block and a new timer instance. We supply proper description. Let's go with class-based for now. And now we are in the inside of the context. The context manager is managing, and everything that is executed here will be measured. So let's say a equals 5 + 5 and b equals 5 + 6, something like that. And if we run this from the terminal, we can see that the description is printed first, and afterwards the time it took to execute this code is printed as well. Okay, so this is the class-based approach. To summarize, we need two methods. The first one is the enter method. This one is invoked if the context is entered. And the second one is the exit method, which is invoked if the context is left right at the end. Okay, so this is the first approach. The second approach is a generator-based approach, and what we do is we first create a generator function. Let's call this one measure exec time. The function does also take one argument, which is a description, and at the beginning we take the current time. Then we need the yield keyword. Then we take the time at the end of the execution and print everything to the terminal. Elapsed time, and we also need to compute the elapsed time before we can print it. So elapsed is end minus start. Elapsed time. Yeah, what actually happens here? So in essence, if the context is entered, we take the current time and assign it to start. The yield keyword can be seen as playing the ball back, so that we continue executing the code within the context. And if the context is left, we jump right back after the yield and continue executing the code lines over here, which is take the current time again, compute the elapsed time, and then print the description as well as the elapsed time to the terminal. At this point, we only have a generator function, but in order to transform this one into a proper context manager, we need a function from the standard library module context_lib. And the context_lib module has a function which we can apply as a decorator, which is called context manager. And this one takes a generator function as an input, which we're doing here by decorating this function, takes it as an input and returns a proper context manager. What we can do now is create another with block with measure exact time, and this time we can also supply a description. Let's go with generator based so that we can distinguish both on the terminal. And yeah, let's take the same code as over here. So A equals 5 plus 5 and B equals 5 plus 6. And if we now hit over to the terminal and execute it again, we can see that first the class-based approach is printed, and secondly the generator-based approach is printed, and that the generator-based approach is slightly faster. All right, that's all for today. At this point, write in the comments which approach you like more, whether it's the class-based approach or the generator-based approach. And don't forget to subscribe to the channel so you won't miss any future videos. Stay curious and keep coding.